Okay, so to understand glacier mass balance, you first need to understand that this is the side profile of a glacier. So this is the slope and this is the glacier, which may have formed in a hollow up here. Who knows? Let's just assume this is the glacier. So higher up, the glacier receives precipitation in the form of snow, sleet, rain, whatever, right? So you have precipitation up here. Okay, let's write that. And the precipitation means that more glacial ice is forming up here. So let's just build some glacier ice onto that. And this is an input to the glacier. Now down here at the snout of the glacier, or it's actually called a tongue if it extends onto open water. So at the snout of the glacier, meltwater comes out because in lower altitudes it's warmer, and so the ice is able to melt at a faster rate or at a higher volume, and you get meltwater out at the bottom of the glacier. Now this is basically a word for the leaving of sort of sediment slash material slash meltwater from the glacier is ablation. Now this meltwater is a big part of ablation, which is just as I said, it was the leaving of material from the glacier. And basically, down the middle of a glacier, you have, or well, this is theoretical, you have the line of equilibrium. Now, in periods where it's really warm, so in summers, the equilibrium line might be further up the glacier because ablation, meltwater, for example, is occurring at a higher rate and temperatures are warmer. So further up the glacier, you have the line of equilibrium, which is basically where precipitation, let's write this, precipitation equals ablation, meaning that there's a sort of there's neither a positive or negative mass balance. It means there's an equal mass balance. So it's losing the same amount as it's gaining at this location. Here there's a positive mass balance, and here there's a negative mass balance because this area is losing more to ablation than it's gaining from precipitation, and this area has a positive mass balance because it's gaining more from precipitation, gaining more ice and sediment, etc., from precipitation, as it's losing from ablation. However, in the winter, the equilibrium line will be a lot further down the glacier because temperatures are overall colder, and so less melting occurs. You have to go super far down to find melting in the glacier. Okay, so when there's an overall positive mass balance in the glacier, which means that it's gaining more ice than it's losing, the glacier will actually continue moving downhill. So let's assume that there's a more of a slope, or it doesn't even have to be downhill. The glacier will just start advancing more because it's gaining more ice than it's losing, so it's able to advance. However, in periods of summer, as I've already mentioned, when there's more ablation, the glacier will start to retreat. So what we see is the glacier actually getting smaller, okay, like so. Let's just get our pen. We see the glacier getting smaller like this, and we can see more meltwater rushing out the glacier. And with this meltwater comes a bunch of sediment, like so, which is basically, sediment is actually also considered part of ablation because it's the loss of mass or loss of just material from the glacier. And you can consider sediment an input. You can't consider it precipitation because obviously it doesn't come from the sky, but further up the mountain it may actually crack off because of freeze thaw, or otherwise known as frost shattering, and it will enter the glacier system. Okay, and this is basically glacier mass balance.